finished the term 1 syllabus. From today I'll be starting the term 2 syllabus. That is from the second book. We have the ray optics. Then we have the wave optics. We have the dual nature of matter and radiation. We have the atomics and nuclear physics. And we have the last chapter, that is the semiconductor devices. So we'll be starting from the first chapter, that is the ray optics. So as I have already told that from the ray optics the reflection part is being deleted. So I'll be not doing the reflection part. I'll be starting from the refraction part. As we already know the refraction part that we have already done in class 10, refraction. Refraction means it is a bending of light rays coming from one medium to the another medium. We have done in class 10 that we have done about the refraction through a glass slab, the refraction through a prism. We'll also do it here, but we'll be calculating the formula of the lateral displacement and the angle of deviation, the topics that we have got in class 10, but we have not calculated the formula in that class. Today we'll be doing that calculation, or we'll be doing the calculation in the later classes. Firstly, I'll be going to start with the refraction. How does the refraction occurs? As everyone knows, for the refraction we need a medium. Okay, and that medium we consider that as a spherical lenses. Okay, we have the spherical lenses, like we have the convex lens, we have the concave lens, and the convex lens or the concave lens can also be divided into three parts, like plano-convex, concavo-convex, okay, and the biconvex lens. Same way we can divide the concave lens also. So we'll be doing about the formula also related with this chapter. What are the lens formula? How to calculate the lens formula? We'll be doing it here. We'll be also doing some part related with the instrument, the optical instruments. What are the optical instruments present? Like we have the simple microscope, we have the compound microscope. Okay, so we'll be discussing about that. Simple microscope is, as a simple example, what is a simple microscope? I think in the smaller classes you have a geometry box. In that geometry box you have a magnifying glass. That magnifying glass is considered as a simple microscope. And if you consider a compound microscope, the compound microscope we used to in the biology lab, that is a compound microscope. And also we'll be discussing about the telescope. There is two types of telescope, refracting type telescope and a reflecting type telescope. So what is the difference between refracting and a reflecting type telescope? We'll also discuss in this chapter. So let us start the chapter. We need to start with the chapter, that is first part, that I'll be starting with the refraction through a glass slab. Okay, so you can see this is a picture of the glass slab. As you can see in the glass slab, this is a thick rectangular piece of glass. Okay, like suppose if you consider this, we can consider the glass slab. Okay, this is a thick piece of glass. We have total how many faces are there? So 1, 2, 3, 4, okay, 5 and 6. Total 6 faces are there, which we have already got in class 10. So you can see in this picture also, this is also 6 faces of a glass slab. So in these 6 faces of the glass slab, what we need to show? We need to show the refraction through a glass slab. So let us show what is the refraction through the glass slab. Let us see. So as you can see, when a light ray enters from the one medium, this is the red line that you are seeing here. The red line, it is starting from one medium, it is entering to the next medium. The next medium is your glass slab. So when it enters into the glass slab, after that you can see it is again going out to the another medium. The outer medium is your air, inside medium is your glass, then again the outer medium is your air. We know that when the light ray goes from one medium to the another medium, there refraction takes place. Okay, so how does the refraction takes place? So when the light ray enters from the air to the glass, okay, when the light ray enters from the air to the glass, air we consider as a optically rarer medium, and the glass we consider as a optically denser medium. Why optically rare medium? The rare medium has the value of refractive index has a very smaller value, and the denser medium has a very high value. If I compare both the values, the air has a refractive index of 1.003, okay, 1.0003, and the glass we have the value of 1.5. So as you can see, the glass is having a value 1.5, so we consider that as a denser medium. And above medium, that is air, because the value is lesser than the glass, that is 1.0003, so that medium we consider that as a rare medium. So when the light ray goes from the rare to the denser medium, as we have already seen that the light ray bends. Okay, the light ray bends. If I show you, so as you can see here, this part. Okay, this part, when the light ray is coming from the air to the glass, it is bending towards the normal. So the normal I will be drawing it here. This is your normal. Okay, so if you can see the picture, I am making it more darker. This line, the black line. Okay, this is your normal. Similarly here, this is your normal. So as you can see, when the light ray is coming from the rarer to the denser, it is bending towards the normal. So this angle, this is the angle of incidence. This angle is the angle of refraction. Again, this angle is the angle of refraction, but since the light ray is going from the glass to the air medium, okay, glass to the air medium, it is bending away from the normal. So this ray angle is called as the angle of emergence, angle of incidence, angle of refraction, angle of emergence. So why the light ray bends towards the normal? Reason behind is that the light ray bends towards the normal because the speed of light decreases. Because of that only it bends towards the normal. And when the light ray goes from the glass to the outer medium, that is the rare medium, it bends away from the normal. Reason behind is that the speed of light increases. Okay, so that is the reason behind why the light ray bends when it enters to the glass and when it goes away from the glass, which we have already got in class 10. Okay, so in the next part, what I will be discussing now, if I extend this line, okay, the incident line, if I extend this incident line, here, let me draw a picture here. Okay, so this one ray will be coming from this side. So again it will be coming to here and it will be bending away here. Okay, so this will be angle of refraction, angle of emergence, looking like straight, but there will be a little bit bending here. So if I consider here, this incident line that I have extended and this line, okay, the refracted line, the distance between these two lines, this line is called as lateral displacement. Okay, this is the lateral displacement. And what is lateral displacement? It is a perpendicular distance between the incident light and the refracted light. And it shows how much amount of your refracted light has been bent. So in the next class, what I will be doing, I will be calculating what will be the value of the lateral displacement. Okay? Thank you for today. We will be continuing from the next class. Thank you.